Good morning, students. Today we are going to learn about the Pythagoras triplets. We already know what is a Pythagoras triplet. 3, 4, 5, the basic Pythagoras triplet, and 6, 8, 10. So I will write on the board. 3, 4, 5 is a Pythagoras triplet. 6, 8, 10 is a Pythagoras triplet. 9, 12, 15 is a Pythagoras triplet. 12, 16, 20 is a Pythagoras triplet. What is the common thing in between all this? Very simple to know this. This is called PPT, not PowerPoint presentation. It is primitive Pythagoras triplet. Now, these Pythagoras triplets are called derived Pythagoras triplets. Sorry, the spelling of Pythagoras is wrong, but please accept that. These are called derived Pythagoras triplets. Now, why it is called primitive? We cannot simplify or take any common factor more than that. What we can say is that all three are relatively prime to each other. That's clear, right? So now we are going to discuss something about that. Really, there is not much to discuss about the derived Pythagoras triplets. We have much more to discuss about the primitive Pythagoras triplets. Okay. Let's take the primitive Pythagoras triplets as A, B, and C. So let's draw a right angle triangle. A, B, and C. Now let's see what's going to happen. According to Pythagoras theorem, C square is equal to A square plus B square. Please remember, children, A, B, C are primitive Pythagoras triplets. They are not derived. That means A, B, C are relatively prime to each other. So C square is equal to A square plus B square. Let's imagine. See, the four cases are possible. First case, even. Second, odd. Third, odd, even. Okay, why I am not considering even odd? This is same, either odd even or even odd, it is same. Now if we consider this even case, even square plus even square is going to be another even. That means our assumption that ABC are primitive prime numbers is going to get contradicted. So that means the A and B both cannot be even. Then they will not be the primitive Pythagoras triplets. They will be somehow the derived Pythagoras triplets. Next, coming to odd. So if we take odd and odd, so you are going to get, okay, let's discuss about it. This is a very interesting case. So let me discuss that. Imagine both A and B are odd and odd. A is equal to 2k1 plus 1 and B is equal to 2k2 plus 1, two odd numbers. So when we square them, we are going to get it. So A square is going to become 4 k3 plus 1. Okay, what is this k3? When I square it, I am going to get 4k1 square plus 4k1 plus 1. So I have taken 4 common and written 4k3 plus 1. Now B square is going to become 4 k4 plus 1. Okay, very good. Now if I add these two numbers, A square plus B square is going to be 4 into k3 plus k4 into plus 2. I'm sorry. So now, okay sir, A and B are odd. When we add them, odd number plus odd number is going to be even number. It is very clear. If a perfect square has to be an even number, it should be the multiple of 4. Otherwise, just a perfect square with just 2 multiple is impossible. It cannot be a perfect square. Now that means A square plus B square should be a 4 multiple. But if you see practically, A square plus B square is not a 4 multiple. 4 into something plus 2. That means even the case of A, B both odd is wrong. So surely one of the number should be odd, one of the number should be even. So let's take number A to be odd number, number B to be even. Now if you add odd plus even, you are going to get another odd number. So this is for sure thing that in a primitive Pythagoras triplet, guaranteed the hypotenuse should be odd number and one of the sides should be odd and one side is surely even. Otherwise the primitive Pythagoras triplet is not possible. Very good observation we have got. Okay. Now let us go into more and more discussion. So in our discussion, what we got actually, let us finalize. A to be odd we have taken, and B to be even, and C to be odd, and they are primitive Pythagoras triplets. Okay, let's go more deep. That is A square plus B square is equal to C square. Now let's write A square is equal to C square minus B square. So A square is going to become C plus B into C minus B. Now carefully observe, we know C and B are relatively prime to each other. Now C plus B and C minus B, and there is A square which is an odd number. Okay, now from here I am just taking a small assumption that let D divide C plus B and D divide C minus B. What I am assuming is there is a common factor for C plus B and C minus B, that is D. So that is what is my assumption. Now we are going to get something abnormal result actually. See this, D divides C plus B and D divides C minus B. What it means, D is going to divide even C plus B plus C minus B, and D is also going to divide C plus B minus C minus B. That means D is going to divide 2C and D is going to divide 2B. So this conclusion is very clear, D is going to divide 2C and D is going to divide 2B. That means the D has to be either 2 or 1. Why I am saying 2? Because these two are anyhow even numbers, so D has to be 2. Now why it is 1? Yeah, it is 1 because C and B are known to be relatively prime. Now the common factor for D, for this one, D to B, okay, D is a common factor for 2C and 2B. Can the D be 2? If 2 divides C plus B and 2 divides C minus B, that means 2 also should divide A square. But according to our assumption, A square is an odd number. So D cannot be 2. That means D has to be 1. That means if C and B are relatively prime, even C plus B and C minus B are also relatively prime. Very good conclusion we have got again. Now two relatively prime numbers are going to get multiplied to give out a perfect square. So for sure this has to be one perfect square, let's call it S square, and this has to be another perfect square, let's call T square. Okay, so very clear assumption over here that since these two are relatively prime, they cannot have any factor in common. Surely this should be a perfect square and this should be a perfect square. Now if you observe carefully, before we got C odd and B even, odd plus even, so that means S square should be an odd number, even the T square should also be an odd number, and this is also an odd number. Clear? So now if you simplify this, please make a note of it. C plus B is equal to S square, we have taken C minus B is equal to T square. So if you simplify these two, we are going to get C is equal to S square plus T square by 2 and B is equal to S square minus T square by 2. I think it's very clear. Now if we want A square, so A square is equal to C square minus B square, nothing but S square plus T square by 2 whole square minus S square minus T square by 2 whole square. So it's going to be A plus B whole square minus A minus B, 4AB, 4 into S square by 2 into T square by 2, nothing but you will get S square T square, or we can write A is equal to S into T. So I think we could derive the Pythagoras triplets, a formulation for Pythagoras triplet. See, there are infinite Pythagoras triplets. What is the proof that there are infinite Pythagoras triplets? Yeah, we are going to prove it. So for all the Pythagoras triplets, there is a way or formalization we can write it. So we got C is equal to S square plus T square by 2, B is equal to S square minus T square by 2, and A is equal to ST. That means I can write it as Pythagoras triplets as ABC. A is nothing but ST, B is nothing but S square minus T square by 2, C is nothing but S square plus T square by 2. And what should be S and T? Good. We got before C plus B is equal to S square, C minus B is equal to T square. We know that C plus B and C minus B are relatively prime to each other. That means even S square and T square should be relatively prime to each other, and there should be odd numbers. So S and T are relatively prime to each other and also odd number. So now we can draw a table. Very simple thing. Okay, let me erase this part of the diagram and write a table. You will understand how there are infinite Pythagoras triplets. S value, T value, ST value, S square minus T square by 2 value, and S square plus T square by 2. Now S can be, guarantee S has to be greater than T because this number is there. Let's take 3 and let T to be 1. Yeah, they are relatively prime to each other and they are also odd number. 3 into 1, 3. 3 square minus 1 by 2, 4. 3 square plus 1 by 2, 5. Okay, take any number. Let's take again 5 and T can be again 1. 5 into 5. So 24, yeah, 12, and this will be 13. I think easily you can calculate that. If you take some 7, let's take T to be 3, are relatively prime and also odd numbers. So 7 into 3, 21, and 49 minus 9 by 2, it's 20. And 49 plus 9, 58 by 2, 29. Yes, correct. So like this, by putting different values of S and T, you can arrive at infinite Pythagoras triplets. So any Pythagoras triplet can be written in any, not Pythagoras triplets, sirs, I am talking about primitive Pythagoras triplets. From this you can derive infinite derived Pythagoras triplets. I am talking about the primitive Pythagoras triplets, which are really most important. S square minus T square by 2, and as any Pythagoras triplet can be written in this form, where S and T are relatively prime and odd numbers. For more clarification on this topic, please contact the number given below. For more personal tutoring, you can please contact that number and you will be getting more and more clarification on this topic. Thank you.